I can hear you.
Okay, thank you. So we're going to start with question 4 here. Find the distance from
Okay.
P to L, and the distance formula is as follows. It's x2 minus x1 squared plus y2 minus y1 squared, square rooted. From P to L. Oh, okay. These are actually longer questions. So 4 comma 3 is a, I can see why I asked this. There's a line containing 4, 3, and minus 2, 0. And let me see if I can draw it here. So 3, 10. Okay, so we need most the room this way. So there's a point 4, 3, 1, 2, 3, 4. I'll only draw it for this first one, and then they're all the same. Minus 2, 0. So there's a line between those two, and then there's a point 3, 10. Okay, so there's a line between these two. Do you agree with that? And then there's this point up here, and there's actually a lot of distances from this point P to L. There's sort of this one that goes this way and one that goes this way, but there's also the shortest one. The shortest one makes a right angle. Okay, so this question has many steps to it, and the first step is to just understand that it's not as simple as just counting. You have to go through a few steps here. So the first step is to find the slope of line L. Okay, so the slope of line L is 0 minus 3 over minus 2 minus 4. So it's minus 3 over minus 6, which is 1/2. The next step is to figure out the perpendicular slope of line L. So the perpendicular slope is the opposite sign reciprocal, something like that. And the reason we need that is because we need the equation of the line that goes through point P. So that's the third step. So you need the equation of the line through point P. So we know point P has coordinates 3, 10. I'm going to use point slope form. So y minus 10 equals negative 2 x minus 3. Okay. So now we have the fourth step here is you have to solve for the intersection. Okay, which means you actually kind of need, there's kind of a 3.5, or you could make it part of step 1, is you have to find the other line. So the other line, it had a slope of 1/2, and I'll use the point of 4, 3. So we have y minus 3 equals 1/2 x minus 4. So you're finding the intersection of these two lines here. Okay, the reason you're finding the intersection is so that you can use the distance formula to find the shortest distance from them. So we'll continue, but like these are the same steps for every one of these problems. So my guess is this is why this was such a challenging problem for you. Just again to be clear, this one comes from step 1, and then we have to find the intersection of the two. So one way to do it is to solve both of these for y. So like this one is y equals negative 2x plus 6 if I distribute the negative, and then to add 10 to both sides. So it becomes y equals minus 2x plus 16. This one we can do the same thing. We can solve it for y. Y equals 1/2 x, you're distributing the 1/2 in here, minus 2, 1/2 times negative 4 is 2, plus 3, so this becomes y equals 1/2 x plus 1. So we can now set these equal. These are very long problems. Minus 2x plus 16 equal to 1/2 x plus 1. I'm going to multiply both sides by 2 to get rid of that fraction. So you get minus 4x plus 32 equals x plus 2. I'm going to subtract x from both sides. So I get minus 5x. I'm going to subtract 32 equals negative 30. So x ends up equaling 6. And then to find y, you can put 6 back into one of these equations. So we'll bring this one down here. 1/2 6 plus 1 is 4. So we're not done. It seems like a lot of work, but we're not done. So we have the point 6 comma 4, and we have the original point P, which is 3 comma 10, and now we find the distance between them. So this is x1 comma y1, x2 comma y2. So the distance is 3 minus 6 squared plus 10 minus 4 squared, square rooted. So that's, in here it's negative 3 squared, so that's 9, plus this is 6 squared, which is 36, square root of that. So this becomes the square root of 45. 45 is reduced, it's 3 and 15, 3 and 5, it becomes 3 square root 5. Now I don't expect any of that to be clear, but we're going to do another example, and you're going to see it's the exact same steps, but we have to go through each of them to make sure there's some understanding. So I'm gonna go to 6. I'm going to skip 5 just because I know the answers in the back for you if needed, but we'll look at 6 next. So 6 has points 4 comma 18 and minus 2 comma 9, and then point P is minus 9 comma 5. So we don't know what this point looks like, but or this line looks like, but it's some sort of a line, and there's some sort of a point, and we have to find the shortest distance between there. So the first thing to do is to find the slope of line L. Okay, so that's the y2 minus y1, 9 minus 18 over negative 2 minus 4, minus 9 over minus 6. That reduces to 3/2. And this is where it's usually good to write the equation of the line in point slope form. So that's y minus y1 equals slope x minus x1. You can use either point, but I'm going to use the first one because it's got nicer numbers in it, both positive. Y minus 18 equals 3/2 x minus 4. This right here, this is the equation of this line. This is line L. Okay, so P is over here, and what we know is that P has a slope that's perpendicular to this one. So the perpendicular slope to L is minus 2/3. That comes from that number there. It's the opposite reciprocal. So we need to write the equation that goes through that one. Okay, so the equation that goes through point P and has this slope, we're going to use point slope form again. Y minus y1 equals the slope x minus x1, and we're going to use this P of minus 9 comma 5. So we're going to write y minus 5 equals a negative 2/3 x minus a minus 9, so it becomes x plus 9. So the next step here is we have 2 equations and 2 unknowns. Okay, we've got this line up here, we've got this line down here, which I'll write as y minus 5 equals minus 2/3 x plus 9. So what we're trying to do here is we're trying to figure out, like, where do they intersect?
Yeah.
And if we can do that, then we can find the distance. So my recommendation, as before, is to solve these for y. So this is y minus 5 equals minus 2/3 x minus 6. When you multiply negative 2/3 in, you get minus 6. Add 5 to both sides, so y equals negative 2/3 x plus 1.
Mm-hmm.
Up and grab this other one here. Let me see if I can grab this. Yep, I can copy that. All right. So now this one, we can solve this. This is y minus 18 equals 3/2 x minus 3 times 4 is 12. 12 over 2 is 6. If I add 18 to both sides, I get 3/2 x plus 12. So we get set these two equations equal to each other. All right, so I'll do that over here. It's minus 2/3 x plus 1 equals 3/2 x plus 12. I'm going to multiply both of these by 6 because that's the common denominator between 3 and 2. So that gives me minus 12 over 3, so minus 4x plus 6 equals 9x, same thing, plus 72. And I'm going to subtract 9x from both sides. I'm going to get minus 13x, subtract 6 from both sides. That gives me 66. That doesn't work. 5, 6. Oh no. Oh no. Oh boy. I'm going to ask you, maybe you saw an error somewhere, because I got to go back and check the work here. All right, 9 minus 18 minus 2 minus 4 minus 9 over minus 6, 3/2. Okay. Minus 2/3. Do you see any mistakes? Oh, maybe minus 9, 5. Okay. Y minus 5 equals minus 2/3 x plus 9. And then we had y minus 18 equals 3/2. 3/2 x minus 4. Just so yeah, I made a mistake somewhere because the solution is nice. Let me see here. 18 over 2 is 9. Negative 12 over 3 is negative 4. That would be 13x. 6. 6. So there is something to this that's not right because the solution is negative 6. What did I make a mistake here? Divide by 2. Oh, negative 4 plus 6. 13x. 18 over 2, 9. Divided by 3, 72. I am not seeing. I wonder if I made an issue in the previous step. Minus 5, minus 2/3 x plus minus 6. Oh, there it is. That should be a minus 1.
Oh.
That should be a minus 1. And that changes that to a minus 1, changes that to a minus 6. That makes that 78. And then it works out that x equals minus 6. All right, so now y is 3/2 times minus 6 plus 12, and that reduces to 3. So the whole goal here was to find, if we could just scroll back here, it was to find this intersection point, which we now have, and the original point. So now we're finding the distance from P, which we were given as minus 9 comma 5. And then the point that we just found, 2, minus 6 comma 3. All the work we did was to find that second point so that we could just use the formula. And you can't just guess it. You can't just be like, oh, I think it's here.
Yeah.
So that's x2 minus x1 squared plus y2 minus y1 squared, square rooted. X2 is minus 6, so minus 6 minus a minus 9 squared plus 3 minus 5 squared, square rooted. Okay, so this negative in here becomes positive, so this is like 3 squared. This is like negative 2 squared, so this becomes 9 plus 4 square rooted, becomes the square root of 13.
Mm-hmm.
We should absolutely do 5, but I think it would be good to see what else what were the other ones you wanted to do?
15 through 18.
They're exactly the same. Okay. Um, so is it okay if I just do the evens for now, since you may not have those?
Sure.
Okay. All right, let's look at 16 next. 16 has points 11, comma, negative 1, negative 3, comma, negative 11. And then
Mm-hmm.
P has coordinates minus 1, comma, 1. Okay. Just like before, we have to find the slope here. So this time the slope is, I guess it's going up this way. It's again, it's kind of a line like that, and there's a point there, and you're trying to find it. So
Mm-hmm.
we're gonna find the slope of L, which is negative 11 minus a minus 1 over negative 3 minus 11. All right, so that becomes negative 11 plus 1 over negative 14. So this becomes negative 10 over negative 14, which is 5/7. Okay. What is the perpendicular slope to that? So that you get it from here, it's the opposite reciprocal. So it's negative 7 over 5. And it's good to right away probably take this one and write the equation of it. So I'm going to go with this first ordered pair here. So it's going to be y minus a minus 1 equals 5/7 x minus 11. So that's y plus 1 equals 5/7 over x times x minus 11.
Mm-hmm.
Now we need to take this slope, the perpendicular slope, and have to use this point and write the equation of the line. So it's y minus, we're using this one up here now, that's coming down here, y minus 1 equals negative 7/5 over x minus a minus 1.
Mm-hmm.
So that's y minus 1 equals negative 7/5 x plus 1. It looks bad. Maybe it works out nicely. I mean, it should. So the next thing to do is to solve both of these for y. I'm going to start this one on the right here. Y plus 1 equals 5/7 x minus 55 over 7. And then when you subtract 1 here, it's like subtracting 7 over 7. So y equals 5 over 7 x minus 62 over 7. Really hoping this works out nicely. This other one, same thing over here. Y minus 1 equals negative 7/5 x minus 7 over 5. When you add 1 to both sides, that's like adding 5 over 5. It's the same denominator. So you get y equals negative 7/5 x
Mm-hmm.
minus 2/5. Let me just check that these have nice solutions before I move much further. These are actually pretty tough to make, to auto-generate. So I would think they would have to have a nice solution, but not always right on that. All right, let's see. Using the, yeah, this actually does have a nice solution. Shocking. So gives me some hope here. So we're going to set these two equal. Negative 7 over 5x minus 2 over 5 equals 5 over 7x minus 62 over 7. So the number to multiply by is 35.
Mhm.
Okay. And same thing over here. So it's always better to divide first. So that's 35 divided by 5 is 7. So that becomes negative 49x. 35 divided by 5 is 7 minus 14. Here, 35 divided by 7 is 5. So that's 25x. 35 divided by 7 is 5. 5 times negative 62 is minus 310. I'm going to subtract 25x from both sides. That gives you minus 74x. Add 14. That equals negative 296. And x equals 4. It actually works out perfectly.
Mhm.
All right. So we're going to take this and put this 4 back into, I don't know, go with that first one there. Minus 7 over 5 times 4 minus 2 over 5. This becomes minus 28 over 5 minus 2 over 5, which is minus 30 over 5, which equals negative 6.
Mhm.
So the last step here, and I'd like you to try this. This will be the interactive portion of the lesson. I want you to go from point P, which is minus 1 comma 1, to 4 comma negative 6, and find the distance for me, please.
Wait, I'm confused.
So I'm just asking you to use the distance for me. This is the final step here. It's the x2 minus x1 squared
Oh,
plus
okay.
y2 minus y1 squared square rooted.
Okay. Could you scroll up a little? Sorry.
Absolutely.
Okay. Um,
So this is 5 squared. This is negative 7 squared. This is 25 plus 49. So you end up getting the square root of 74.
okay.
So it's really critical that we understand that, like, all of these problems, what they do is they give you 2 points that are on a line, and then they give you a third point. So we use those 2 points to first we get the slope, and they've been calling this L, so we'll call it the slope of L. We use the
Mhm.
slope of L to write the equation of the first line.
Yeah.
Okay, then we take the slope of L and we turn it into its perpendicular slope perpendicular. Once we find that perpendicular slope, we write the equation of the second line.
Mhm.
So we're basically getting two lines. The third thing you do is you find the intersection. So that gives you that second ordered pair. Like in this
Mm-hmm.
previous problem, we got that other ordered pair, and then the very last step is to use the distance formula.
Mm-hmm.
Formula to find the distance. So you know how to do every one of these steps individually.
Mm-hmm.
Problem is do you really want to do them all? Like, do you want? The problem is when you got to do them all together.
Yeah.
So I guess what I'm saying is like the problem the reason these problems are so challenging is you have like a bunch of steps to do.
Yeah.
Okay, let's do another one. 18, and these are, I mean, these are really tough. I remember working with a student, and they had this little tiny area to work on these problems in their test, and these were massive problems. 4, -1, and 4, 9. Okay, so this is an exception. Okay, and the reason it's an exception is because it means it's either a horizontal or a vertical line.
Mm-hmm.
If you're not sure which one it is, you plot the points. Okay, there's my origin. 4, -1 is there, and 4, 9 is up there somewhere. So this is a vertical line.
Yeah.
Vertical lines always have the formula x equals a number. In this case, it's x equals 4. The point, the point that you're trying to find the distance to is 1, 6. Okay, I actually do need a little more. So let me redraw this with some more space because I didn't realize where we were at. Okay, so we've got the point 4, -1 and the point 4, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got that. And then we've got the point 1, 6. 1, 2, 3, 4, 5, 6. The shortest distance between these is this line right here. Now you can absolutely go to the trouble of finding the slope, finding the equations of the line, setting them equal, finding the other point, and using the distance formula. But when it's two perpendicular lines like this, you just count. Count. So the
Mm-hmm.
distance is this right here. It's 3.
Yeah.
So the summary of this is that when you get one of these exceptions, you're literally just counting. So let's see if I can
Mm-hmm.
find another one here that's like that. 20. We'll do 20 real quick, and then we'll go back and do one of the more difficult ones. So 20 is the other exception. So 20 has the line containing -8, 1, and then 3, 1. So here's my axis right here. -8, 1, 1, 2, 3, 4, 5, 6, 7, 8. So right there's the first point, -8, 1. And the other point is here, 3, 1. A horizontal line contains them.
Mm-hmm.
The point that we care about is -2, 4.
Yeah.
-2, 4. What is the distance between these? Well, it's right here. It's this perfectly perpendicular place.
Mm-hmm.
So that distance is 3.
Mm-hmm.
Um, So those two examples, I mean, you'll probably get one or the other on a test, because sometimes you get two of these, but those are like compared to the ones we just did, they're very straightforward because um, they're they're same. Why don't you try 17? And then
Okay.
we'll definitely have time for at least one more. Try 17. It's one of those exceptions, and let me know when you come up with the answer here. You definitely want to plot the points to help. All right, so here's the points, -2, 1, negative, and then 4, 1. That's a nice horizontal line. That's good. And then the point 5, 7. So 5, 1, 2, 3, 4, 5, 6, 7. There's the point P. That's 5, 7. This is, again, one of those nice cases where you just drop that perpendicular straight down, and then you're literally just counting. What distance did you come up with?
6.
So we're counting from here. So 1,
Oh,
2, 3, 4, 5, 6. Perfect. Yep. So those are good. Like, you want those, but you probably only get one of those in the test or quiz or whatever. We got 15, 17, 19, and then number 5, I think. So I guess I'll just work backwards. These are really long. I mean, I would probably get worn out trying to do these as a student back in the day, but we'll do 19. So L contains points 1, 5, and then 4, -4. And point P is -1, 1. So we talked about our steps. The first thing is to find the slope of line L. That's the y2 minus y1. So -4 minus 5 over 4 minus 1. So that's -9 over 3. That's -3. From here, we want to write the equation. I'm going to just choose the first one because it seems like they're both positive. Y minus y1, 5, equals -3x minus 1. Okay. Then we need the perpendicular slope to L. So that's +1/3. That comes from that right there. So we write the equation of it with this point here, y minus 1 equals 1/3 x minus -1. So we can reduce this, y minus 1 equals 1/3 x plus 1, sorry, x plus 1. Now we have to find the intersection of these two lines. And I suggested solving them for y. So we'll do that with the first one here, y minus 5 equals -3x minus 1. We're going to solve it for y. So y minus 5 equals -3x plus 3. We're going to add 5 to both sides. So that ends up being +8. This one is y minus 1 equals 1/3 x plus 1/3. If we add 1 to both sides, adding 1 is like adding 3 over 3. So it's 1/3 x plus 4/3. So if y equals 1/3 x plus 4/3, we now have to set these equal. So that's -3x plus 8 equals 1/3 x plus 4/3. And I'm going to multiply both sides by 3 to get rid of the denominator. On the left, that's negative 9x plus 24, you're just distributing in, equals x plus 4. And then what we're really hoping is that this works out really nicely. If you subtract x from both sides, you get minus 10x. If you subtract 24 from both sides, you get minus 20. So x equals 2. Yay. And then we're going to pull one of the equations. It doesn't really matter. I guess we'll use this y equals minus 3x plus 8. So we're going to substitute 2 in, minus 3 times 2 plus 8. So that ends up being, sorry, this is an 8. I don't know why it's not drawing nicely. Negative 6 plus 8, so that becomes 2. So our ordered pair is 2, 2. The original p is negative 1, 1, and you just have to find the distance between them. So the distance is, I'll write the formula again, x2 minus x1 squared plus y2 minus y1 squared, square rooted. So this is negative 1 minus 2 squared plus 1 minus 2 squared, square rooted. So that's negative 3 squared, that's 9, plus negative 1 squared, that's 1. Distance is the square root of 10.
Okay.
All right, we got time for one more. 15, 17, or number 5. Do you have a preference?
It doesn't matter.
All right, I'll just do 17. They're all kind of the same. This is good practice. Like if you really want to learn this skill, like your instructor's done a good job of saying, okay, these are the, oh no, we already did 17. 17 is an exception, so we'll do 15. 17 has negative 2, 1, and 4, 1 as the points. Those are on a horizontal line. That's why it's an exception. So we'll do 15. So 15, line L has 0, negative 3, and the point 7, 4, and point P is 4, 3. Okay, the slope of L is 4 minus 3 over 7 minus 0, 7 over 7, which is 1. So we're going to write the equation of the line. I'm going to actually use this point over in the left because you end up getting the intercept slope of 1, x minus 0. And I'm just going to go ahead and solve this. It's y plus 3 equals 1x, y equals x minus 3. So the next thing we need is the perpendicular slope to L. So that's the opposite reciprocal of 1, which is negative 1. And then we use this point down here. So we go y minus 3 equals negative 1, x minus 4. And then we simplify here. So that's negative x plus 4. And then we add 3 to both sides. Y equals negative x plus 7. Then you set these two equal to each other because we're trying to find that other point where they intersect. So that's negative x plus 7 equals, what did I say, x minus 3? Yeah, x minus 3. If we subtract x from both sides, you get minus 2x. If you subtract 7 from both sides, you get negative 10. That means x equals 5. And then y is equal to x minus 3. 5 minus 3, because that's the x value, is 2. So we have the ordered pair 5, 2. And we're trying to figure out where the distance between it and 4, 3. So that's the distance formula. We got y2, or actually x2 minus x1 squared plus y2 minus y1 squared, square rooted. So that's 4 minus 5 squared. That's, again, x1, y1, x2, y2. y2 is 3 minus 2 squared, square rooted. So that's negative 1 squared plus 1 squared, 1 plus 1, square root of that. Distance is equal to the square root of 2. All right, so this is a great place to finish. I'm going to send you these notes as a PDF right away. I'm sure you'll need them. And I'll
Okay.
try and send you the link tonight to upload for the video. It's been taking slightly longer for Zoom to send them to me for some reason. But that's
Okay.
it. Thanks for scheduling, and I look forward to helping you next time.
Thank you for seeing me.
You're welcome. Have a good night.
Thank you.
Bye.
Bye.